All right, so we're back for more.
Back for more, yeah.
And we're going even deeper into this electric universe stuff and the bioplasma bodies.
Yeah, we barely scratched the surface last time.
Yeah.
You've given us a ton more to dig into.
Yeah, you guys sent in some like crazy research papers.
Oh, yeah.
Some interviews with people who I never even heard of before.
Yeah, it's amazing stuff.
Historical accounts.
Yeah.
So we're ready to really like go deep on this one.
Fasten your seatbelts.
Yeah, so last time we talked about how this electric universe idea is saying like, hey, the universe isn't primarily about atoms.
Right.
It's more about plasma.
Yeah.
Which is a huge idea, right?
Absolutely. It throws out the textbook and says, hey,
Yeah.
we need to rethink this.
Exactly. Yeah. So
What's interesting, too, is that, like,
yeah.
we think of ourselves as these solid beings walking around,
Yeah.
but really we're made of the same stuff as stars.
Yeah.
Plasma.
So it's not just about the stuff that stars are made of,
Right.
but the stuff that we're made of too, right?
Yeah.
But what makes plasma so important to study?
Well, for one, it's the key to understanding how stars work, how galaxies form, and even the origins of the universe itself. But there's more to it than that.
Okay, like what?
Well, one of the most fascinating things about plasma is that it doesn't always behave like a typical gas. It can self-organize, forming these intricate structures like filaments, spirals, and even crystals.
Crystals. I thought crystals were solid things.
Ah, that's where things get really interesting. Plasma crystals are a bit different. They're formed when charged dust particles within the plasma arrange themselves in these ordered patterns. And get this, some scientists believe these crystals might be the key to plasma's ability to store and process information.
Hold on. Information. Are we saying plasma could be like a cosmic computer?
That's a concept we'll definitely explore further down the line. But before we get ahead of ourselves, let's take a step back and look at how our understanding of plasma evolved over time. Did you know the idea of a fifth element beyond earth, air, fire, and water goes all the way back to ancient Greece?
Wait, like Aristotle and his ether.
Exactly. Aristotle envisioned this ether as a special kind of matter that filled the heavens. He even proposed that living beings possessed a corresponding etheric body, which we might now call a bioplasma body.
So like a spiritual energy body.
It's a fascinating concept, and one that we'll revisit later when we delve into the mysteries of bioplasma. But for now, let's fast forward a bit to the 19th century, when the scientific study of plasma really took off. It all started with a brilliant inventor named William Crookes.
Crookes? Rings a bell. Wasn't he the guy who invented those glowing glass tubes?
You're thinking of Crookes tubes. They were these partially evacuated glass tubes that contained low-pressure gas. And when high voltage was applied, something amazing happened. The gas inside became ionized, creating this glowing stream of charged particles.
So he created a miniature lightning storm in a bottle.
A very poetic way of putting it. And those tubes weren't just a cool spectacle. They were actually the first demonstration of plasma in a laboratory setting.
I remember seeing those in high school physics. It's amazing to think that something that seemed so simple back then actually laid the foundation for so much of modern technology.
Absolutely. Those Crookes tubes paved the way for the development of things like X-rays, neon lights, and even the cathode ray tubes that were used in early televisions. But while Crookes gave us the tools to create and observe plasma, it was another brilliant mind, American chemist Irving Langmuir, who really put plasma on the map, so to speak.
So what did Langmuir do?
In 1928, while studying ionized gases in those very same Crookes tubes, he coined the term plasma to describe this fourth state of matter. He was also instrumental in establishing plasma physics as a distinct field of study, exploring its properties in depth.
So he gave it a name and started figuring out how it actually works. That's pretty groundbreaking.
Absolutely. He systematically investigated plasma's electrical conductivity, its interaction with magnetic fields, its tendency to form waves and oscillations. Basically, he laid the groundwork for our modern understanding of plasma. But as with any scientific endeavor, there were plenty of mysteries and surprises along the way.
Oh, I love a good scientific mystery. What kind of surprises?
Well, one of the most baffling and persistent puzzles in plasma physics is the phenomenon of ball lightning. Ever heard of those eerie glowing spheres that sometimes appear during thunderstorms?
Yeah, ball lightning.
Oh.
Always sounded like something out of science fiction.
Right. It's incredibly difficult to study, but scientists generally agree that it's a real phenomenon and that plasma plays a key role. But what makes it so fascinating and frustrating for researchers is that it can exhibit some truly bizarre behavior.
Like what? What makes it so bizarre?
Well, it can pass through solid objects, hover in midair, and even explode with incredible force. We still don't fully understand what causes it or how to replicate it in a lab.
That's wild. So even though plasma is everywhere, it still holds plenty of secrets, even right here on Earth.
Exactly. And as we zoom out from our planet and explore plasma's role in the vastness of space, things get even more mind-boggling.
Okay, now you're really intriguing me. What happens when we take plasma to the cosmic level?
Well, we've already touched upon stars and auroras, but those are just the tip of the iceberg. Have you ever heard of Birkeland currents?
Birkeland currents. Can't say that I have.
Imagine massive, invisible rivers of charged particles flowing through space, carrying energy across unimaginable distances.
Whoa, like a cosmic power grid.
Exactly. And some scientists believe those Birkeland currents might even be the key to understanding how stars are born and how galaxies are shaped.
Okay, that's officially blowing my mind. So it's like stars are plugged into a giant cosmic grid fueled by these currents of plasma.
Precisely. And this idea is at the heart of a theory known as the electric universe model, which we'll be discussing in more detail.
An electric universe. Wow, I'm definitely going to have to tune in for that.
But before we jump ahead, there's another fascinating aspect of plasma that's a bit closer to home, literally.
What do you mean?
Well, remember how we talked about Aristotle's concept of the etheric body?
Yeah, that ancient idea of a spiritual energy body made of this mysterious ether.
Right. Well, fast forward to the present day, and some scientists are exploring the possibility that a form of plasma, known as bioplasma, might actually exist within our own bodies.
Wait, you're saying we have plasma inside of us? What does that even mean?
It's a fascinating area of research that we'll be diving into next. For now, let's just say that bioplasma might be more intimately connected to life than we ever imagined.
Okay, this deep dive is already blowing my mind. So from ancient philosophy to glowing tubes to cosmic power grids to the possibility of plasma inside of us, it seems like plasma is more than just a state of matter.
You got it. It might be a fundamental force that connects everything in the universe, from the smallest particles to the largest structures.
Well, I can't wait to learn more.
Plasma is wild stuff, highly conductive, carries electric currents, doesn't play by the same rules as solids, liquids, or gases.
So you're saying that space is basically a giant electric playground?
Pretty much. And all those electric currents flowing through space, those could be the real powerhouses behind stars, galaxies, you name it.
Now you're talking. That sounds way more exciting than just plain old gravity. But what about the sun? Didn't we learn it's a giant nuclear furnace? How does that fit in with all this electricity?
Well, the electric universe theory proposes that the sun isn't actually powered by nuclear fusion in its core.
Whoa, whoa, whoa. Hold on a second. Are you saying the sun isn't a nuclear reactor? Where's all that energy coming from then?
It's getting its juice from external electric currents flowing in from its surroundings.
So the sun's more like a giant light bulb plugged into the cosmic power grid.
That's a good way to think about it. And it explains a lot of things that conventional astronomy has trouble with, like sunspots.
Sunspots. Those cooler, darker patches on the sun's surface.
Right. The electric universe model suggests that sunspots are areas where the electric current flowing into the sun is disrupted.
Makes sense. It's like a dimmer switch on a cosmic light bulb.
Exactly.
Okay, I'm starting to see the light, pun intended. But where's all this cosmic electricity coming from in the first place? Is there some giant power plant out there we haven't found yet?
It's more like a vast web of interconnected circuits. Electricity flows through these plasma filaments that stretch across unimaginable distances, linking everything together.
So instead of one big power source, it's more like this constant flow of energy between everything in the universe, like some cosmic internet of electricity.
You got it. Everything's connected, influencing everything else. And that interconnectedness is a key part of the electric universe idea.
I'm starting to see how this could really turn our understanding of the universe upside down.
And it gets even wilder when we start to consider how this electric universe might connect to us right here on Earth.
Okay, now you've really got my attention. You're saying there's a connection between this cosmic electric web and us humans. I'm all ears.
Well, think about it. If the universe is this giant electric circuit and we're part of that universe, doesn't it make sense that we might be electrical beings ourselves?
Now you're speaking my language. I've always been fascinated by the idea that our bodies are these complex electrical systems. Our nerves are like tiny lightning bolts, right?
That's right. And the electric universe theory suggests that our bioelectricity might actually be interacting with these larger electric currents flowing through space.
Hold on. Are you saying we're like walking antennas picking up signals from the cosmos?
It's an intriguing possibility. And there's growing evidence that our bodies are much more sensitive to electromagnetic fields than we used to think.
This ties into some of the more unconventional research we're exploring.
Okay.
Remember those death flashes, these bursts of light, sometimes observed at the moment of death? Could this be linked
Possibly.
to the release of the bioplasma body?
It's a fascinating question.
It is.
There are accounts
Yeah.
of a faint glow or mist observed around individuals at the moment of death.
Wow.
While some attribute it to biochemical processes,
Yeah.
others speculate it could be the bioplasma body separating from the physical form.
So like a kind of energetic leaving the building moment. That's this bioplasma body thing, right?
Exactly. You're not just a collection of atoms walking around. You're a walking, talk
I love that.
plasma being.
Yeah.
And what's really mind-blowing is that this bioplasma isn't just some static energy field.
Right.
It's deeply connected to information.
Information.
Yeah.
Like our memories and experiences.
Yeah, think of it like this. Your bioplasma is like this record of your life.
Okay.
But it's not just a passive recording.
Right.
This information, this energy is constantly interacting with your physical body
Uh-huh.
and influencing your thoughts, your emotions, even your health.
So like if I'm stressed out,
Yeah.
it's not just chemicals in my brain going haywire.
Right.
It's like my bioplasma is freaking out too.
Yeah, you could put it that way.
Okay.
Eileen McCusick, who's been researching this for years,
Okay.
actually found that when people are under stress, they emit more biophotons
What are biophotons?
or tiny little particles of light.
Okay.
Like our bioplasma is literally glowing under pressure.
Okay. Now that's trippy.
Right.
But how does this energy like actually become information?
Yeah.
Is it like a code or something?
Well, that's where it gets even more fascinating.
Okay.
This guy, David Bohm, who was a brilliant physicist,
Mm-hmm.
had this concept of active information, which basically flips the script on how we think about information.
All right.
You know, we usually think of information as passive data,
Right.
like something you store on a computer.
Yeah.
Bohm said, no information is active.
Oh, wow.
It's shaping reality.
So the information in our bioplasma isn't just sitting there.
Right.
It's actually influencing what happens to us.
Imagine, like, your bioplasma is like a cosmic sculptor,
Okay.
constantly shaping and reshaping your physical reality
Oh,
based on the information it holds.
that's wild.
It's why two people can have the same experience,
Right.
but react to it completely differently.
Yeah.
Their bioplasma is interpreting that information in unique ways.
I see.
Yeah.
That makes sense.
Yeah.
So hold on. Remember how we talked about Peter Mitchell last time?
Oh, yeah.
The guy who proved that these tiny currents of protons
Right.
exist within our cells?
Yeah.
He basically said that our cells are like mini electrical circuits.
Yeah, he got a lot of pushback for that idea. Oh, yeah. At first, people thought he was crazy.
Wow.
But he ended up winning a Nobel Prize.
Good for him.
And what's cool is that his work aligns perfectly with this whole bioplasma concept.
Oh, really? How so?
Well, if we're essentially walking, talking electrical beings,
Okay.
then those tiny proton currents are like the sparks of life
Oh.
that keep our bioplasma buzzing.
So like our cells are like little power stations
You got it.
for our bioplasma body.
And those proton currents aren't just random sparks. They're carrying information. It's like a cellular internet, connecting everything in your body through this intricate web of energy and information.
Okay, my brain is officially starting to melt.
It's about to get even weirder.
Oh boy.
We haven't even gotten to the truly mind-blowing stuff yet.
Okay, bring it on.
All right, so next we're going to zoom out from the human body
Okay.
and explore the possibility that plasma itself
Yeah.
might be intelligent.
Okay.
And that leads us to some pretty incredible discoveries in our cosmic neighborhood.
This just keeps getting wilder and wilder.
Oh yeah, we're just getting started.
All right, well, don't go anywhere, folks, because this is just part one.
Stay tuned.
We're going to take a quick break, and we'll be right back with more mind-blowing stuff about the electric universe and bioplasma bodies.
All right, so remember how we were talking about how the universe is basically swimming in this electric plasma soup?
Yeah.
And that even we're made of it?
Yeah, crazy thought.
But here's where things get really tricky.
Okay.
What if plasma itself
Uh-huh.
can develop intelligence?
Intelligent plasma.
Yeah.
Are we talking like sentient clouds or something?
Not exactly clouds as we picture them,
Okay.
more like plasma structures.
Okay.
So remember how we were talking about information being active,
Right.
shaping reality?
Yeah.
Robert Temple,
Okay.
who's really been a pioneer in this whole electric universe thing,
Yeah.
he takes that idea a step further.
Okay.
He suggests that if plasma can hold and process information,
Uh-huh.
then under the right conditions, it might actually be capable of developing some form of consciousness.
So, like, the universe itself could be thinking.
Well, think of it this way.
Okay.
The human brain is incredibly complex.
Right. Yeah.
Billions of neurons firing,
Yeah.
creating this network of electrical signals
Right.
that give rise to our thoughts and feelings.
Okay.
Now imagine that on a cosmic scale,
Whoa.
plasma flowing through the universe,
Yeah.
interacting with magnetic fields,
Uh-huh.
forming these vast structures over billions of years.
Okay.
Who's to say that kind of complexity
Yeah.
couldn't lead to something akin to consciousness?
I mean, I guess you're right.
Yeah.
So it's not like there's some giant cosmic brain out there.
Right.
It's more like intelligence could emerge
Exactly.
in these plasma structures.
Yeah, and there's actually a pretty compelling example of this
Really?
right here in our cosmic neighborhood,
Okay.
the Kordylewski clouds.
But what now?
Kordylewski clouds.
That sounds like something out of a science fiction novel.
They kind of are.
There are these massive, faint clouds of dust and plasma that orbit Earth.
Okay, giant clouds near Earth.
Yes.
How did we miss those?
They're incredibly difficult to observe
Okay.
because they don't reflect a lot of light.
Oh,
It's like trying to spot a dust bunny in a dimly lit room.
okay.
But what's really mind-blowing about these clouds
Yeah.
is that they seem to be incredibly ancient.
How ancient are we talking?
Maybe billions of years old.
Billions of years old.
And incredibly stable.
So they've been hanging out near us this whole time.
Just doing their cosmic thing,
Wow.
orbiting Earth along with the moon
Uh-huh.
in this delicate gravitational dance.
And that's what makes them so interesting.
Yeah, in the context of intelligent plasma,
Okay.
they've had billions of years to evolve, to interact,
Right.
to potentially develop some form of consciousness.
Hold on. Are you saying these Kordylewski clouds
Yeah.
could be like alien brains?
Well, not brains as we know them,
Okay.
but temple.
And another scientist, Professor Chandra Wickramasinghe,
Okay.
have actually suggested that these clouds could possess a level of intelligence
Uh-huh.
that's beyond anything we can comprehend.
Okay. That is seriously messing with my reality right now.
It's a lot to take in.
So we could have these potentially super intelligent plasma beings
Yeah.
right next door, and we've been clueless this whole time.
It really makes you wonder what else we might be missing.
Yeah.
Welcome back to our exploration of the electrifying world of plasma.
You know, after that last part, I'm seriously starting to see plasma everywhere I look. Like, even my coffee mug seems to be vibrating with hidden energy now.
Well, maybe not your coffee mug. But it's true that once you start to understand the nature of plasma, you start to see the universe in a whole new light.
It's kind of like those 3D images where you have to relax your eyes just right, and suddenly this hidden image pops out. Except, in this case, the hidden image is like the entire universe.
That's a great analogy. And to really grasp the full implications of plasma, we need to consider how our current understanding of physics might be a little bit limited.
Limited, you mean like there are things we're just plain wrong about?
Not necessarily wrong, but perhaps incomplete. For instance, take the standard model of particle physics. It's our best attempt to explain the fundamental forces and particles that make up the universe.
Yeah, I've heard of that. Quarks, leptons, bosons, all that stuff.
Right, but there are some pretty big gaps in the standard model. Like, it doesn't really have a good explanation for dark matter and dark energy.
Oh yeah, those mysterious things that supposedly make up the vast majority of the universe, but we can't actually see.
Exactly. They're like these giant question marks in our cosmic equation. But here's where plasma gets really interesting.
Okay, I'm all ears. How does plasma fit into all of this?
Well, some plasma physicists believe that dark matter and dark energy might not be these exotic, unknown particles that we've been searching for.
So, no tiny invisible ninjas hiding in the fabric of space-time.
Probably not. Instead, they propose that what we perceive as dark matter and dark energy could actually be manifestations of large-scale plasma phenomena.
Plasma phenomena. Like what?
Think about those Birkeland currents we talked about earlier. Those massive invisible rivers of charged particles flowing through space.
Yeah, the cosmic power lines. I'm still trying to wrap my head around those.
Well, imagine those currents interacting on a galactic scale, creating huge electromagnetic fields that influence the movement of stars and galaxies.
So you're saying that instead of needing these mysterious invisible particles, we might just be seeing the effects of plasma behaving in ways we don't fully understand yet.
That's the idea. And it ties into the electric universe model, which proposes that electromagnetism plays a much bigger role in the universe than we previously thought.
The electric universe. That sounds familiar. Didn't we touch upon that in the last episode?
We did. Remember how we talked about stars being powered by those Birkeland currents? Well, the electric universe model takes that idea and applies it to the whole cosmos.
So galaxies are like giant circuits with plasma as the electric juice.
That's a great way to visualize it. And the exciting thing is that the electric universe model isn't just some wild speculation. It's making predictions that are being confirmed by actual observations.
Really? Like what kind of observation?
Well, for example, space probes have detected vast magnetic fields and currents throughout the solar system and beyond. They found evidence of Birkeland currents connecting the Earth to the sun. They've even observed these massive jets of plasma shooting out from the poles of galaxies.
Wow. Cosmic fireworks.
Yeah.
It's like the universe is putting on a light show for us. And we're finally starting to understand the language of the performance.
Exactly. And the more we learn about plasma, the more it seems like it could be the key to solving some of the biggest mysteries in astrophysics.
Okay, I'm starting to feel like we need a bigger whiteboard to keep track of all of this.
Yeah.
But let's shift gears for a minute. We've talked a lot about the cosmic implications of plasma, but how does all of this research actually impact our everyday lives?
You might be surprised to learn that plasma technology is already having a huge impact, often in ways we don't even realize. Let's start with electronics.
Electronics. I thought we were talking about stars and galaxies, not smartphones and laptops.
Well, it turns out that many modern electronics rely on plasma technology. For example, have you ever heard of plasma etching?
Plasma etching. Nope, doesn't ring a bell.
It's a process that uses plasma to create those incredibly intricate circuits found on computer chips.
Oh, so the tiny brains of our devices are thanks to plasma.
In a way, yes. And plasma technology is also used in the manufacturing of things like flat-screen TVs, solar panels, and even those energy-efficient light bulbs.
So plasma is lighting our homes, powering our computers, and entertaining us with TV.
Precisely. And that's just the beginning. Let's move on to something that's becoming increasingly important: the environment.
Okay, this should be good. How can plasma help us save the planet?
Well, plasma technology is being explored for various environmental applications like water purification, air pollution control, and even waste treatment.
Wait, you're telling me plasma can clean up our messes?
In a sense, yes. For example, there are plasma reactors that can break down harmful contaminants in wastewater, making it safe to reuse. And some of these reactors even produce clean energy as a byproduct.
So we could have clean water and clean energy, all thanks to plasma. Sign me up.
And there's more. Plasma can also be used to remove harmful gases and particles from industrial emissions, essentially cleaning up the air we breathe.
Wow. From powering our cities to cleaning up our planet, plasma is starting to sound like the ultimate multi-tool for a sustainable future.
It certainly has a lot to offer, and the more we learn about plasma, the more applications we're likely to discover.
It's almost like plasma is this hidden superpower waiting for us to unlock its full potential.
That's a great way to put it.
But let's get back to the more unconventional applications of plasma.
Okay.
We talked about the possibility of using plasma to interact with the human biofield. Can you tell us more about that?
It's a fascinating area of research.
Yeah.
Some researchers are experimenting with various forms of plasma technology, like plasma tubes and plasma generators, to see how they can influence the biofield.
So I've heard of people using these even for enhancing consciousness. Are there any scientific studies to back up these claims?
Research in this area is still in its early stages, and more rigorous scientific studies are needed to validate these claims. It's important to remember that with any powerful technology, there are potential risks to consider as well.
Right. Like what kind of risks?
Well, for starters, plasma is complex. It's highly dynamic and can behave unpredictably, which makes it challenging to control and manipulate.
So it's like trying to tame a wild beast, but the beast is made of superheated, electrically charged gas.
Exactly. And that's why safety protocols are crucial in plasma research. We have to be incredibly careful to ensure that experiments are conducted safely and that we're not putting anyone at risk.
Makes sense. We don't want any accidental mini supernovas happening in the lab.
Definitely not. But despite the challenges, the potential benefits of plasma technology are so vast that it's worth the effort to explore it responsibly.
Okay, I'm starting to see that we're really at a turning point with plasma research. We're starting to uncover its incredible potential, but we also need to be mindful of the possible downsides.
That's exactly right. It's a delicate balance, but one that's worth striking.
Well, this has been an incredible journey so far, and I'm feeling more energized than ever about the possibilities of plasma. but I think my brain needs a little time to recharge before we dive into the next level of mind-blowing concepts.
I hear you. Let's take a quick break, and then we'll be back with part 3 of our plasma-powered adventure.
Welcome back, everyone, for the final part of our plasma-powered deep dive. Last time, we were on the verge of venturing into some serious sci-fi territory.
We were indeed. And now we're ready to explore those mind-bending concepts in more depth. Are you ready for a glimpse into a future shaped by plasma?
Absolutely. Bring on the futuristic tech. Let's start with something we touched upon earlier, plasma computing. You mentioned that it could revolutionize the way we process information.
It has the potential to be a game changer. Remember those plasma crystals we discussed? Those tiny self-organizing structures that might hold the key to those cosmic brains?
Yeah, the ones that could potentially store and process information on a cosmic scale.
Well, some scientists believe that those same crystals could form the basis of a whole new kind of computer, one that runs on plasma.
A plasma computer, what would that even look like? Would it be like a giant glowing orb in a lab somewhere?
It probably wouldn't be quite that dramatic. But the concept is to leverage the unique properties of plasma, like its self-organizing abilities and its sensitivity to magnetic fields, to create a computational system that's far more powerful and efficient than anything we have today.
So we're talking about a computer that's not limited by the physical constraints of silicon chips. A computer that can process information at the speed of light.
Potentially even faster. Imagine a computer that can perform parallel processing on a massive scale, handling trillions of calculations simultaneously.
Okay, now my brain is starting to melt. What could we even use that kind of computational power for?
The possibilities are practically limitless. We could model incredibly complex systems, like the human brain or the Earth's climate, with incredible accuracy. Imagine designing new materials and drugs with atomic precision, or finally cracking the code of quantum mechanics.
Wow, this sounds like the ultimate scientific tool. But those are some pretty lofty goals. What about more practical applications? How would plasma computing impact our everyday lives?
Imagine artificial intelligence that's not just intelligent, but truly conscious and self-aware. Picture virtual reality experiences that are indistinguishable from real life. Think about medical diagnoses and treatments that are personalized down to the individual cell.
Okay, now we're talking. That's some serious future tech. But how far off is all of this? Are plasma computers just a sci-fi fantasy, or could we actually see them in our lifetime?
It's hard to say for sure, but research in plasma computing is advancing rapidly. We're already seeing progress in developing plasma-based transistors and other components, so it might not be as far-fetched as it sounds.
I can't wait to upgrade my smartphone to a plasma-powered model. But let's move on to another sci-fi favorite, space travel. We talked before about plasma propulsion systems, but what other spacefaring wonders could plasma technology unlock?
Plasma could be crucial for developing advanced spacecraft shielding, protecting astronauts from harmful radiation during long-duration missions.
Right, because space is a pretty harsh environment. But what about something even more ambitious, like artificial gravity? Is that something plasma could help us achieve?
It might sound like science fiction, but some physicists believe that by manipulating magnetic fields and plasma, it might be possible to create a kind of artificial gravity field within a spacecraft.
Whoa, hold on. You're saying we could have spaceships with their own gravity, just like in the movies.
Mm-hmm.
Astronauts could walk around normally instead of floating around like, well, astronauts.
That's the idea. It would make long-duration space travel much more comfortable and less damaging to the human body.
That would be a game changer for space exploration. No more zero-gravity wobbly legs. But let's push this even further. We've talked about plasma's potential for healing, energy, computing, space travel. But what about its ultimate potential? Could we harness plasma to manipulate the very fabric of reality itself?
That's venturing into the realm of speculative science, but it's certainly a fascinating thought. Some physicists believe that plasma might hold the key to understanding the fundamental nature of space and time.
Okay, hold on tight. Now we're going down the rabbit hole. Were we talking about things like time travel and teleportation, wormholes that connect distant parts of the universe?
Those ideas have been explored in science fiction, and while we're a long way from achieving anything like that, plasma research could provide us with a deeper understanding of how those seemingly impossible things might actually work.
Okay, my mind is officially blown. Plasma is starting to sound like the ultimate key to unlocking all the secrets of the universe.
It's a bold statement, but consider this. Plasma is the most common state of matter in the universe. It's also involved in some of the most powerful and fundamental processes we know of, from the birth of stars to the creation of black holes. So who knows what wonders we might uncover as we continue to explore this remarkable state of matter.
Well, folks, that brings us to the end of our incredible deep dive into the world of plasma. We've gone from the basics to some truly mind-boggling possibilities. From healing our bodies, to powering our cities, to potentially reshaping our understanding of the universe itself, plasma has revealed itself to be much more than just a fourth state of matter. It's a force of nature that connects us all, a source of both wonder and caution, a reminder that the universe is far more mysterious and awe-inspiring than we could ever imagine.
And remember, we've only just begun to scratch the surface. Who knows what incredible discoveries await us as we continue to unravel the mysteries of plasma.
It's an exciting time to be alive, that's for sure. Thanks for joining us on this incredible journey into the world of plasma. Don't forget to like and subscribe so you don't miss out on our future deep dives into the unknown. Until then, keep those minds curious and keep exploring.